Howdy, I stumbled across this one. Seascape, the state of our oceans. Discovered it in the deep, the incredible fish with a transparent head. The rare barrel-live fish tracks its prey with extremely light-sensitive rotating eyes, encased in a see-through canopy. Yeah, this dude must be very open-minded. Now that's some incredible species. That's amazing. The barrel-live fish has extremely light-sensitive eyes that can rotate within a transparent, fluid-filled shield on its head. The two spots above its mouth are similar to human nostrils. Whoa. Yeah, that's something to look at. But we can also look at the crop estimate of the year 2022, situation 15th of August. Information corrected. According to the current estimate, the 22 grain harvest will return to normal after last year's peak year. The oat yield estimate is higher than 10 average yield, while the rye yield, on the other hand, is almost a quarter smaller. The 2022 crop estimate on August 15 from finished fields. Estimated grain yield in total 3.6 billion kilos, 38% more than last year. Barley, 34% more. Oats, 56% more. Wheat, or however you spell that, 29% more. Rye, 3%. Rapeseed, 41. Potatoes, 1%. Peas, 109%. Broad beans, 83%. So obviously they started to plant peas recently and beans. And I was thinking that this sounds very nice. There is stuff growing in Finland. Despite all the drought and all these kind of things, we had very long drought. There's still drought going on in Europe and also here in Finland. The sun is shining again. Kursk magnetic anomaly, surface conductivity anomaly, greetings. And I was thinking about that. How so? Everyone is crying about the drought in many places, or has been in recent weeks. Now there's water coming. Pakistan know what I mean. And I think it's rather simple. If we go over to Google Earth, you will notice that there is a whole lot of water in Finland. There's like lakes everywhere. Bigger and small ones. But if you zoom in, you will find water all over the place. Like everywhere. Savijärvi. This means clay lake. So, there is no glaciers. There is no snow in summer, not even in the north. But not too far from here, a few kilometers, there's the Lake Kuorinka. It is a medium-sized lake in the Vuoksi main catchment area. It is located in the region of northern Karelia, Finland. Whole lake and the shore are protected in Natura 2000 conservation program due to the lake's oligotrophic waters containing very few minerals of sandy plains. So we have to click once again on oligotrophic. Oligotroph. An oligotroph is an organism that can live in an environment that offers very low levels of nutrients. They may be contrasted with copiotrophs, which prefer nutritionally rich environments. Oligotrophs are characterized by slow growth, low rates of metabolism, and a generally low population density. Oligotrophic environments are those that offer little to sustain life. These environments include deep oceanic sediments, caves, glacial and polar ice, deep surface soil, aquifers, ocean waters, and leached soils. I want to point out aquifer. Like I said, there is no glaciers here. We are not underground, we are not in a cave. So, aquifers is the only which fits here from these. Deep oceanic sediments, caves, glacial and polar ice, deep surface soil, aquifers, ocean waters, and leached soils. Aquifers. So, this is just one of those I've found until now of these oligotroph lakes. I guess there are many more here because we have thousands of lakes. The region where I live here is very interesting. We have the plasma rock site in the city. And between where I live now and the plasma rocks, there is a very interesting area geologically. There are many little lakes and ponds, and it's actually quite hilly. You know, there's like small hills. They're all arranged in approximately the same direction. Some of those little lakes are very deep, and they are very clear and very cold. But they remain lakes. They don't dry up. They are just there, like all the thousands of lakes of Finland. So I would say almost all of them are fed from below. Which brings us back to the crop yield this year in Finland. Like, if there is drought and you have those fields, probably you have also the equipment to bring the water in. Throw the pump into the lake and pump it into the field, because there is water always. It's not like Germany or Switzerland when the rivers are drying, there's no water anymore anywhere. Here it's just like everywhere. That's why the crop yield in Finland is probably so good, because they had the possibility to bring the water into the fields. Many farmers, when they leave to a certain field, they have to drive a quite long distance because there's a lake in between. So there is water to bring it onto the fields. And it was warm, almost hot. Sun was shining constantaneously. So the thing is, there is the amount of water which has been here in the last several hundreds of years or thousands of years. But it might change. The water level might change, because there might be fluctuations. With the Kursk magnetic anomaly and the surface conductivity anomaly, we have two things which are implicating that there has been some rather massive electromagnetic event in the past which created those anomalies. And since they are imprinted in Earth's crust, they won't change until the next time. But until it's that far, they will make the connections to the heavens in their very own ways. I still think the red area in the surface conductivity anomaly is positively charged, which attracts high pressure systems. And the blue parts are the negatively charged. They would attract low pressure systems. But since we know that energy goes always both ways, this also means it can switch around. It can be the total opposite. But mainly, the positive regions will attract high pressure systems and such. This is also very important in order to understand the directions of the winds, because they will flow in the according direction to the polarization of the crust and the interaction with the heavens. And if Earth's core, or how to put it, the mantle, if the mantle is already shifting or has shifted or is still shifting, probably it is shifting all the time. But if there isn't too much stuff going on from outer space, so to say, they won't matter too much. But if the energy input or the energy circuit is just amped up, like we can see now at the sun with sun cycle 25, those things in Earth's mantle, as we have seen on Mars, I made a video about that too, with those patchy northern lights, aurora borealis on Mars, they were all over the place. They were interacting with the surface of Mars. So it will do the same thing on Earth. It's just a matter of time. And there is like so much clay land here. And I have been thinking about clay quite some time now. And I came to the conclusion it must be something which comes out of the ground. Hence, volcanic activity. Mud volcanoes. And I have been talking about mountain water, glaciers being actual contemporary lava flows are made out of water, and every glacier carrying mountain is a volcano, which is erupting through water. And they are discharging all the time because there are all those water wells in the mountains. And it's not too far-fetched to think that why a volcano wouldn't erupt with water since it's so abundant. It doesn't have to be always lava. Water. Let me show you one example of a volcano who does this, erupting with water. For this we go to Costa Rica, sorry. Poas Volcano Stratovolcano, 2,708 meters, dormant. Eruption style. Phreatic eruptions, sometimes geyser-like ejections of water from the acid crater lake. Poas is one of Costa Rica's most active volcanoes and one of its most frequently visited and prominent ones. It contains a green acid crater lake, and during some of its frequent phreatic eruptions, water from the lake is ejected like a geyser. And somewhere I have been reading it can be as high as 4 kilometers. No, I would say that's a geyser. 4-kilometer high water fountain. And it's acid. And as we know, nature will always provide also the opposite. So why shouldn't be there anywhere on else a volcano which is erupting with water, and it could be also perfectly drinkable water? I don't think that's something to dismiss as a possibility. But anyway, maybe because of that, the crop yield in Finland this year seems rather good. Whatever implications this might have in the future. Let's see. Thank you. Bye.